So isn't it always the way that you kind of wrestle with a problem for a while and then two solutions come along almost exactly at the same time? Having been wrestling with my level shifter for a while to try to get 3.3 volt and 5 volt devices on the same network, I now obviously have two different approaches that both work very well. Using the kind of the level shifter board, which I have here, it has 10k pull-ups on both sides of the board. So you can actually make these work fine with PJON. What you need to do is to add pull-down resistors to kind of balance out those pull-up resistors. And then that will work just fine. Or I now have my diode-based resistor divider solution as well, and that's working well as well. And, you know, I thought for a while, okay, well, I could kind of evaluate the reliability of these two and the speed and do some network testing. But the problem with that is I could spend ages kind of, you know, getting the perfect results for just that component of the puzzle. And I kind of need to crack on. There's you know, perfection is the enemy of good or something like that, isn't it? It's good enough. This is working fine. I will note at the back of my mind I now have another potential way to fix the networking levels problem as well. If I have problems with this, I can return back to that. But what I really want to do now is to make it look more like a game, to move away from these kind of testing units which I've just been using to test the network connectivity, and to move into something that looks more like something that the player can actually solve and interact with, them some puzzles. So these are all puzzles which I have made in this channel in the past. So I've got a connect the wires puzzle where, you know, you take crocodile clips or whatever and connect the terminals there. So that's kind of quite basic there. I've got a keypad puzzle here, and I've got some, you know, switches puzzle where you set the switches to the right level and things like that. And what I want to do now is to kind of integrate these puzzles with these kind of basic controllers that I had down here that I was using to test the network. So the idea is that, keeping with this idea of it being modular, I want to have kind of like a core functionality that all these devices are going to have. And I kind of wrote that in my code anyway. I have this idea of the state of a puzzle. It's either you know, active or solved or deactivated and things like that. I want to have some kind of status indicator as well. So I've kind of toyed around with various indicators here. And every device should probably have a name, so every module is going to have a unique name, things like that. And the idea being is that I haven't yet chosen exactly how the devices are going to be connected to the network. At the moment I've got them sort of wired into these screw terminals, but what I really want to do is to have like a push-in simple terminal connector, whether that's an RJ45 or whether that is screw terminals or whether it's you know, some other simple connector that this network is not fixed. I'm going to have these modules here, and depending on which ones you've plugged in, the master controller is going to, when it first boots up, kind of ping every device on the network, work out what's there, and then set up the game accordingly. So to do that, what I need to do a little bit more is to think about those kind of common features that all the modules are going to have, and I guess to be able to monitor the status of that. And so to do that, I'm going to look a little bit more at the simplest of displays, which is like what kind of LED status are they all going to have. So in my last video I was showing how you could monitor the status of the puzzles by loading kind of multiple copies of the Arduino serial monitor window, and then kind of having each puzzle controller send a serial .print message or something like that via a separate USB port. And that was kind of fine, but I was getting kind of a mess of wires because I was having each individual device had to have its own USB thing plugged in and things like that. So what I wanted to do is have a more kind of visual indication on the front of the board what the status was, both kind of while I'm developing it, but also I thought that would be useful output to the player. And the most obvious way to do that is probably with an LED. Because you can convey sort of lots of different states with an LED. Even with just one LED, you can have it being solid, or you can have it blinking at different rates, or you can have it off and things like that. So I started off looking at just basic LEDs. So I've got different coloured LEDs here. And originally I started off with just the idea of a red and a green one. So the red was going to come on. Well, originally I was going to have it so that there were no LEDs on, and a red was for failure and a green was for success. And then I kind of modified that a bit and go, well, actually, I want to have a way of not only showing that a puzzle is failed or solved, but actually whether it's available for solving or not. So like in a normal escape room game, you wouldn't have all of the puzzles available to the player kind of all at once. You know, you'd have different areas that they'd discover, and I kind of wanted to kind of simulate that in the box, I guess. Even though everything may be laid out in front of them, I wanted some puzzles to not be initially accessible to solve. So I kind of wanted some way of showing whether the puzzle was even like activated or online or available, whatever you want to call it. And then from then I wanted another one to say, okay, has it been solved? So then I sort of changed the meaning of the red and the green lights. So when they're both off, that meant the puzzle was deactivated. When the red light was on, that meant that it was active but not currently solved. And then when the green light came on, that was solved. And so I kind of went with that idea for a bit, but I wasn't totally happy with the layout. And I thought, well, actually, rather than needing a red and a green LED, I could make this a bit simpler by simply using a single LED that had RGB components in it. So if you've not seen these before, an RGB LED, basically, if I can actually even get the packet open. So these are exactly the same form factor as a regular LED, except that they actually contain diodes for each of the three primary colours, and you can wire to them separately. So it doesn't take any less pins up than separate LEDs. Well, it does, I suppose, because they've got a common ground, they've got a common cathode. But you still have to drive each LED separately, but it just means it takes up less physical form factor on the board. So I was going to use one of those, and then I thought, well, actually, if I'm going to be able to have red and green separately, why don't I actually use a programmable LED? So you're probably familiar with Neopixel strips. I've used them a lot in my projects. They're very popular in kind of Arduino projects. And I thought, well, I could just cut a single Neopixel LED and have that as my indicator, and then I can not only have it being red and green and flashing and blue and white, but all these other interesting patterns as well. And there's lots of great libraries available for Neopixels that show kind of different animation patterns you can do on them. And then I remembered another type of LED which I used in a project a while ago, but I've not really seen them used very much since, and I don't know why, because they're actually they're pretty handy. This is a PL9823 LED. And the funny thing is it looks like an RGB LED again, in that it's got 4 legs, you can see. However, it's not. It actually works the same way as the Neopixel does. So it's a programmable LED. It's actually got like a tiny microprocessor in here. And what you can do is you can chain a whole series of them together. So you can chain them like this and then program a sequence and animation, but using the form factor of a regular LED, which means you can kind of place them in sockets like this. So there's the main disadvantage of these is actually seems to be, like I said, not many people use them, which means there's not a whole lot of documentation or examples for them. But I have used them before. So in terms of wiring, if you kind of look at them from the front here, you don't know if you'll be able to make this out or not, but this side here, this has kind of got a flat edge, whereas this is a beveled edge. And you can also see on the pins, we've got 2 longer pins on this side. So at the flat edge side, we've got 2 long pins, then we've got 2 shorter pins. And the way to wire it is starting from the right hand end here. So this shortest pin on the right hand end, that's a data in line. And then we have +5 volts, then it's ground, and then it's the data out. So if you did want to connect a whole series of these in a row, you could do that by taking the data out from this one into the data in line, which is the yellow one I've got here, if I can actually untangle that. And like I say, just like Neopixel strips, you can then have a whole array of these and create chase patterns and things like that. So I decided actually I'd use these in this project instead. So I need to wire some of these up. The other difference is, unlike Neopixels, where you should have a resistor in the series in the data line and also a capacitor. These, certainly if you're only using a single one, you can wire directly to a GPIO pin on the data line and to 5V and ground. So I'm going to use these. I'm going to wire some of these up, and I'm going to use that as my kind of status indicator, both in the kind of the finished puzzle, as it were, for player indicator, but also during development. I'm going to use this as a status indicator to let me know, when each of the puzzles has come online and whether they have pinged the master controller recently and things like that.
Yes, 6 points. Prisoner was the title of a recent hit single with Dua Lipa.
So because I'd already made kind of each of these puzzle types in the past anyway, I basically had most of the code ready written, and all I've done is I've gone into each one and just made the changes necessary to kind of add the PJON interface and also just that LED status display. So this is the switches puzzle here. So I've added in fast LED, which is the library I'm using. This is what I use to control Neopixels if I'm using them, and it will control the PL923 LED grade as well. Then I've got the PJON library here, so I add those in. And then these bits here, so this is what I copied in from my network example earlier. I just set the PJON switch, create a bus with a specified module name. So basically every puzzle type I create is going to have a different unique module ID, and then the idea is that when the code first starts up, the master controller can ping all of the device IDs possible. So let's say I say there's going to be a maximum of 32 different puzzle types. I mean, that's quite a lot of puzzles, but let's say I come up with 32 different puzzle types. I'm going to name them with IDs between 1 and 32. And when the controller first starts up, it's just going to try and ping every ID between 1 and 32 and see which one responds. That's basically the same way that an I2C scanner works to detect the device ID of any connected I2C devices. It literally just tries to ping every address and it just sees which one comes back. So it's the same idea here basically. I'm going to give every type of puzzle a unique ID and register on the network using that ID, and then when the controller tries to ping it, you'll see in the callback here I've got responses to various messages that the controller can say. Now again, I haven't totally settled on these yet, so I'm going to use enable and disable just so that the controller can kind of turn all of the units on and off when the game starts, but also individually enable modules to enable this kind of progression throughout the game, as modules come online, as to sort of simulate a game flow progression. We've also just got a ping interface. This is what happens right at the beginning when the game first starts. If we receive a ping, it responds with the name of this module, so the master controller knows what's there. And then what you'll see at the bottom is in the loop here, so this is just all the regular code I was using already for a switches puzzle, and what I've added in is first of all this bus.send to let the master device know the state of the puzzle, but also these little lines here that update the colour of the LED, so we can see physically the status of the LED. So it turns green when it's solved up here, for example. When it's inactive, it's just off, it's black, and when it's active it has this sort of glowing red feeling. So rather than having to plug in a USB connector and look at a serial monitor to see what state each of the puzzles in, I've got this very visual indicator on the front. And I've kind of done that in each of the different codes. So if we have a look at the connect the wires puzzle as well, so same idea. This was an existing puzzle that I already had written, and I've just added in the same things again basically. So we've added in the module ID at the top, and this one will have a different module. So this is module ID 9. So from then on, every time we see that there's a module with the device ID 9 on the network, we know that there's a connect the wires puzzle in this game. That at least is going to be the idea.
again, we've got the same. You'll notice like large portions of this code is the same as what it was in the other one, and all I've done at the moment is copied and pasted them directly into the sketches. What I should probably do, and what I will do when I've settled on the common kind of interface that I want each of the modules to have, is I'll move this into a module or like a library, and then I will simply get each of them to include that library at the top, just like you include third-party libraries like this. Basically, I'll move all of this common functionality into a library of its own, so that I don't have to copy and paste it in between different files. At the moment, I haven't done that because it's, I'm kind of writing it differently in each code, because I'm trying different things out as I go along to see what works and what doesn't. But same idea again. So see the PJON using software, so that's the network interface, and then I have the LEDs interface, which I'm using with the fast LED library. And initially we add the LEDs, set the LEDs to black when the puzzle's inactive, and then depending on the device state here, so black if it's inactive, and then we turn it to glowing red if it's active, and then if it's solved we turn it to green. So same again.
Now, another thing I've noticed about the kind of the network design is the way it looks at the moment. It looks like we've got the master controller here, and then all the other devices are kind of wired in serial to it. So we've got our power and our ground and our signal line first going to this device, and then we've got them going onto this device, and then we've got, and it sort of looks like they're in a chain. That's not actually necessarily what we want to happen. That's not actually how the network works either. We can have this just as a sort of a star-based network. And the other thing I sort of forgot to mention, I suppose, is that I'm using the 3 lines here to connect both our single wire data interface and also to provide power to all the devices as well. I've currently got that running off the V-in pin on the ESP32. So the ESP32 is a 3.3 volt device, but it's got 5 volt powered to its V-in pin 5, which is fine because it's got a step down converter here, and that means that 5 volts goes to all the other devices, and that's okay as well. But even though the ESP doesn't regulate the power on the V-in pin, that current still has to pass across the traces on the chip itself. And so we've got whatever devices we've got connected here, which is the processor itself, and then maybe this has also got the case of the LED here, and it's got this the new LEDs we've added, all the rest of it. So all this current here is coming from the V-in pin of the ESP32, which, like I say, has sort of had to run off the copper trace of this board here. So that's probably putting quite a lot of strain on that. So what I'm going to do is to sort of change the network layout so that not only is not only are we not sort of trying to take a serial line in turn all through here, it's sort of centralized, but also that the power supply is centralized, and we're not trying to kind of pass power through any device in order to get one of the other ones. So so we've got like a centralized thing. So I've got I've mentioned Wago connectors before, and I've used Wago connectors. These are obviously quite chunky Wago connectors. These are 8-way Wagos. And I'm going to have these kind of centrally somewhere, and then what I'm going to do is to have each device connected to those central connectors. So let's just take these off. So this device here, for example, we can have one of these Wago connectors will be for power, one will be for ground, and one will be for data. And so this will be more of a star design for the network. Now, I don't know if like I said, I don't really know if I want to use the physical way of connecting these devices. I don't really know what it is I'm going to use. I want something that can be easily well, makes a secure connection for one thing when it is plugged in, and can be relatively easily swapped over. I'm not expecting people to change the modules all that often, so it doesn't need to literally be kind of snap in and outable, but it does need to be relatively easy to change. But in theory, Wagos could do it, I suppose. If I had an exposed Wago connector at the back of the box somewhere, and when you slotted a new module in that you wanted to change the game, what you do is simply find an unused slot here and connect your new module into it, and that would kind of automatically place on the network. I haven't quite decided yet, but yeah, this is I'm going to change this design like this now. So it's a little bit tricky to see because it's not supposed to have, but hopefully what you can see now is I've got the master controller itself is connected here. I've got one slave device down here, and I've got another slave device over here, and these can be 5 volt or 3.3 volt devices. And what I might try to do is get a variety of different other microprocessors so that each puzzle controller can be using an Arduino, or it can be using a WeMOS, it could be using ESP or a Raspberry Pico, or whatever you want. They all connect to this central network. The level shifting circuitry is all attached on the local module itself anyway, and nothing is trying to draw power through the circuitry of another device as well. So I kind of tidy these wires up, and then I'll sort of show you that circuit. And what I will do now actually is I'll connect these panel devices into that as well. There we go. Now obviously the cable tidies aren't really necessary. You'd normally put that on like the very last stage of a project, but I just think it helps tidy it up a bit as well, and means that I don't accidentally get the wires caught up in each of these things, and it kind of makes it more obvious that each module is individually wired. That contains the power, the ground, and the data lines as well, all in one neat little package. So I've had a bit of a tidy up of the wiring here. Ironically, I've then introduced some more complicated wiring again in order to be able to demonstrate the connect the wires puzzle. But you kind of ignore that for one moment to one side. Hopefully what you can see is I've got the master controller here, and each of the 3 sub puzzles I've got here now just has their own single bundle of cables going to them, and that is coming from a kind of a centralised distribution in the middle here. So this is like a star network. We've got a central point for 5 volt ground and the data connection, and then each of the spokes coming off that star is going to a separate module. And I've now got the power here coming from an external 5 volt power supply as well. So rather than using the USB power, which was going to one of the devices in the network and then kind of passing along the chain through each previous processor, now there's a central power that each one is drawing from. So that's kind of how that's set up. And now what I'll do is I'm going to briefly disconnect that power and just plug it back in again, so you can kind of see the power cycle when it first comes on. We'll get a switch. So long term, that power supply will come from a battery, like I say, which I can just turn on and off. So when the case first fires up, the idea is that these modules, each puzzle module is disabled by default, it's inactive, because I want to kind of have that way of restricting what the players choose to interact with at the beginning. So if I make it seem like it's not currently working, you can press the buttons and nothing will happen, I'm hoping that will stop players and kind of guide them more towards a series of puzzles that they actually have to follow in order. The one that does have some lights on it is the master controller, which has like a little LCD display, and I've stopped displaying the countdown on this now. I'm going to do the countdown just on one of these two, the idea being that I want to use this display for actually displaying text and hints possibly and things like that as well. But at the moment it just says detecting modules detected, which is kind of the startup sequence. But the idea being that when I press this button, which is kind of the go button at the moment, what will happen is that the countdown will start and the modules will become active. So what you see here is that the keypad and the switches module have become active and they've started glowing red. The connect the wires puzzle at the moment is not active, so that will become available when another puzzle is solved, let's say later on, things like that. I think I've actually put this on a toggle, so if I pause it, they will deactivate again, the time pauses. If I toggle on again, you'll see that this time round these three have become active. So the idea being that you could have kind of different playthroughs where the puzzles come available in a different order, let's say, or something like that. But now they've all become active. So they are being controlled from a message sent from here, and you can actually see on the radar here, activating, pause, activating. If I now, let's solve one of these puzzles. So if I, if I solve the connect the wires puzzle, for example, because that's almost completely solved anyway. So I'm just going to plug this last cable in. And when I do so, what you'll notice is that the light here goes green, but also, hopefully you can see on the display here, it says received S from module 9. So S is a solve, I'm saying at the moment. I need to be more consistent in exactly what terminology I'm doing like that. But my point is, so the controller forced the units to start up. The units, the puzzles report back to the main controller when something happens. So if I do the same on the keypad, so if I try to type something on the back, I put my finger on the back of the pad there and pressed a lot of buttons. That was a really bad example, wasn't it? So let me try that again. Let's try 1, 2, 3, 4. That solves that. And again, you can actually see in the output here, well, it's showing you all of the things that were received there. And now if I go to the switches, and the switches, I think I need to turn 5 down. Oh, I can't remember what the solution was. 4 and 5 up. There we go. So that has solved all the puzzles. And now what would probably happen now is that I'd expect the countdown to stop, or for another puzzle to get activated, let's say. And I need to kind of think about the logic of how I want to do that. But one more thing I can show is if I just unplug the solution to that and change one of those switches, because obviously those are kind of lapsed states. If I now press the button again, you can see I can reset that back to the initial state with them all unsolved again, kind of thing. So that's kind of where we're up to.